Welcome students. As I have said that this is the part 3 of our series of number system. In this particular video we will be understanding how to convert the fractional numbers, which is basically one of the very important questions that is asked by the examiner. At first we will be dealing with decimal to binary. Okay, I will be giving one example. With the help of example we will be dealing with this particular question. Okay, so let's say the number that I want to take is 1 3 dot we can take 6 2. Okay, suppose this is my decimal number and I want to convert it to binary. Okay, when numbers were not fractional, I have already explained in my previous videos. You can watch them first, then you can come to this particular video. Okay, so how to convert 13? We know how to convert 13 to the binary. I will be simply dividing it. 2 6 jar, 2 3 jar, then 2 1 jar 2, remainder is 1. So 1 0, sorry, 1 1 0 1, 1 1 0 1. We already know how to place these numbers. 1 1 0 1 is the placement of the numbers. Now we need to think for this decimal part. Can you see? 6 2, right? So how to perform this? See, you need to first take the decimal part like this, and what you need to do, as here we are talking about binary numbers, so we need to multiply it with 2. So let me multiply. So what I'm getting, 2 2s are 4, 6 2s are 12, and this is 1. Okay, now what I need to do, I need to escape this one or remove this one, and whatever decimal expression I have got, I need again to multiply it. So let me multiply. 2 4s are 8, 2 2s are 4.0, and here I will be again be taking the non-decimal part. Sorry, here it is 0, right? Yeah. Then I will be taking again 0.48 into 2. Then it will be 6, 8 to the 16, then 9. Yes, again 0. 16, 9. Again my question, the non-decimal part is 0. Okay, so here what will I be doing? I will be start placing from this to this. 1 0 0. Now what was my non-decimal part? It was 1 1 0 1, and my decimal part has given me 1 0 1. See, whatever you have got over here, you need to keep them, sorry, it is 0 1 0 0. Now you must be having one question in your mind. So till when shall we be multiplying 2? It's up to you. If the question is demanding that you need to go for 4 number of digits after the decimal place, then you need to multiply it, you need to multiply 2 4 times with the number whatever you are getting. Here, as you can see, I was in expect of 3 digits only. That's why I have multiplied 2 times. And do remember, can you observe this transaction? I have only taken the decimal part. Here at my result was 1.24, but I have kept my 1 over there, and I have only taken 0.24, and I have multiplied. Again I will be following this process. If suppose the question would have been take till 4 number of digits, so what would I be doing? I will be again taking 0.96 into 2, and this is 6 2 is 12, 8, and this is 9, this is 1. Okay, this is my result, and here I will be again be taking my non-decimal part of this particular expression, that is 1.92. So I can also implement 1 over here if I want to expand it to my 4 number of digits. It's always up to you. Okay, have you understood? So this non-decimal part we have already discussed in our previous class. Now you must be understanding how to deal with my decimal part. Okay, now we will be learning how to convert a binary expression to the decimal, the two if it will be fractional one. So let me take 1 1 0 1. Okay, let me take 101 this time. This is my decimal, so it will be expressed in this particular manner. At first, what we need to deal with? We need to deal with the non-decimal part. And as usual, 1101, I will be naming it 0123 as I was naming it. Then 2 to the power 0 into the number 2 to the power 1 into the number 2 to the power 2 into the digit. Then 2 to the power 3 into the digit. With this we have got 8 plus 4 plus 0 plus 1. Okay, so what have I got? I think 13. Okay, now what will I be doing? I will be taking this decimal part and see my decimal part is this. Now listen to me carefully. What you need to write over here, as we were writing 0, 1, 2, 3 from right to left, here we need to think of left to right. And here I will be writing -1, -2, -3. Okay, so with this what will I be doing? I will be doing the same job. So 2 to the power -1 into 1, 2 to the power -2 into 0, and 2 to the power -3 into 1. So what will happen over here? 2 to the power 1. So it is of course 1 by 2. 2 to the power -2 into 0, it will lead to 0, so 0. And this is 2 to the power -3, so 1 by 8. So after solving this, it's 5 by 8, right? And if I will be dividing it with approximately, I can follow this particular procedure. I will be multiplying 125 to both of my expressions. So the denominator I will be getting 1000, and the upper one I have got over here 625. So with this what happened? Whole of my expression I have got the result 0.625. So I will be just taking off that. See, this is 13, and now I will be writing 625 over here. Here it has led to my 0.625. So if 13 is there, you will be adding 0.625 to it. You can follow any of the expression. Directly I have written over here. Otherwise you can follow this. 0.625 plus 13 leads to 13.625. This is what my answer will be. This is how you need to convert your binary expression to decimal if it will be fractional in form. Okay, you need to must note it down whatever I am teaching over here, so that it will be helping you to understand all of the elements. Now let me talk about octal. So octal 2, let me take 25 point, let me take 4. Okay, so this is my octal. I will be converting it to binary. So as usual, non-decimal part, what were we doing? We were expressing each digit in 3-digit binary form. So here it's 5, so here I will be breaking 101, and it's 2, so 010. Okay, then dot, and the 4 also I will be converting it into binary form. It's easy. 4 will be 100, so I will be writing 100. That's all. This is how you need to convert your octal to binary. Okay, now binary to octal, the ulta one, right? Okay, so let me take 10101.100. Are you noticing what I am doing right now? See, previously my answer was 1101.1001. So here, that is why I have taken 1101.101. Can you see here? Here we have got 13.625, and if you will be observing the previous question, it was 13. This is how I am taking the expressions. See, here in my octal to binary, my question was 25.4, and this is what I have got in my result. And as you can see, I'm just ignoring this first digit 0, and I'm taking the entire expression. And here, whatever methodology I will be using, my answer need to be 25.4. Okay, that is what our aim is. Okay, at first let us follow the process. So likewise, if 10101 is the one, I need to first divide it with 3 digits. So if I will be dividing it with 3 digit form, so 101 will be 5, 0 1 0 will be giving me 2 as usual. Then point, then again this 1 0 0 will be converted to what? It will be converted to 4. That's all. My binary is now completely converted to octal. And you see, I have got my result. Similarly, I will be doing something in my hexadecimal. Hexadecimal to binary, similar things. I will be making, let's see. Suppose here I've taken 2 f dot a. Okay, let me take this. Now, how to deal with this? So, convert this f to binary, but with 4 digits. So, a is 10, b is 11, c is 12, d is 13, e is 14, f is 15. So f is nothing but 15. I need to convert my f to my binary. So 15 means it will be 1 1 1 1. Yes. Now I need to do the same thing for my 2. 2 is 1 0, right? So 0 0 1 0. Okay, because every time, as I've said in the previous class, you need to use them in 4-digit form. That's why here, even though the result of my 2 in binary is 1 0, I have used 0 0 1 0. Then dot, then I need to think of a. So how to convert this a? A is nothing but my 10. So if I will be converting 10 to binary, so eventually it will be 1 0 1 0. Okay, now it's done. This is how my hexadecimal is converted to binary. Now if I will be converting binary, see, I am taking the same expression 1 0 1 0. Okay, I am taking the same expression 1 0 1 0, and I will be dividing it with 4-digit pattern. So 1 1 1 1, and this is I am having 1 0, then I will be adding 2 zeros, and here I am having 4 digits. So I will be replacing this with f, this with 2 point, this will be a. See, now it is successfully converted to hexadecimal. It's very easy, right? Very easy is whenever you are converting binary to hexadecimal, hexal to binary, everything. But when it comes to decimal, it slightly becomes little lengthy. Question you will be getting easy. So here, octal to decimal, right? So let me take the same question, 25.4. Now I need to think how to convert octal to decimal. Let's first deal with this non-decimal part. How were we converting? Do you remember? Okay. This I will be taking 0. This I will be taking 1. Then 8 to the power 0 into 5 plus 8 to the power 1 into 2. If you are unable to get how I am dealing with non-decimal numbers, then there is already a video just previous of this particular video. You can go through that to understand this properly. And now let me talk about the decimal part. Okay, after doing this all things, what I need to do? This 4 is given, right? So here I need to write 4 is my decimal part, so it will be minus 1. Why? Because it's my decimal part. Now I will be taking 8 to the power minus 1 into 4. Suppose here I am having 2, then 2 will be given minus 2, then plus 8 to the power minus 2 into 2. This is what you need to follow, and at last you need to add them. I know it's going to be a little lengthy, but let's me try it out. This is 5, this is 8 to the 16. So here we have got the answer as 21. But this would be 1 by 8. 1 by 8 into 4. Achha. Then plus 1 by 64 into 2. If we will be solving this, this is 1 ja. Then 8, let me keep in the remainder, 2 4 ja, 8 1 ja, 5 by 8. If I will be taking 125, so it will be 1000 at the below. Then 6, so it will be 0.625. What will I be doing? I will be adding, so 21 plus 0.625. So my answer is 21.625. and this time I have decimal with me. Okay, this is how you need to convert your octal to decimal. Now let us think about the reverse. Suppose somebody has given me this and I need to convert into octal. How were we converting this 21? Just think how our decimal was converted to octal. The non-decimal part, we used to convert, we need to divide it with 8. 8 to the 16. 6, 17, 18, 19, 20, 21, 5. Then I used to take 8 zeros are 0. Remainder is 2. So 25. My non-decimal part is already over. Remember students, every time you must be observing, I am first solving the non-decimal part, then I am solving the decimal part, and I am doing this separately. Okay. Now I need to think of how to convert this. How to convert my this particular 625. Okay. So for that I need to take 625. 625 will be taken 0.625. And do you remember students how I was converting my decimal to binary and all? See, could you remember this particular process? How my decimal was converted to binary? I used to multiply it with 2, right? And I used to keep the decimal part that was included in my original number. So don't you think I will be following similar process to do this particular thing? So here I will be doing the similar thing. How to convert decimal to octal? I will be multiplying it with 8, because as there I was converting it to binary. That is why I was multiplying 2. But here I need to multiply 8. Okay. Would you understand what I'm saying right now? Just a moment. Yeah. Now, yes, I need to multiply. It will take little time, but we can deal with this. 16 into 5. Okay. Directly I have got this. Just let me check, just a moment. Here if I will be taking the decimal part, it's 5. 0.625. Have I done wrong somewhere? Just let me check this. 16, 17, 19, 20. 5, then 0, then 5. It will be 5 there. Okay. So 25. I have already got 5 if I will be taking the decimal part. So it will be 0, 0 everywhere. So it's good. We have got 5 over there. So I will be taking the non-decimal part when I am multiplying it with 8. That is 5 I have already taken. I will be simply be taking that 5 and I will be just keeping it with 25 after my decimal point. Okay, this is how we need to deal with whenever the question will be convert decimal to octal. Here, okay, we will be now talking how to convert hexadecimal to decimal. Just think for a moment how these things can be done. Okay, now I will be giving you some references. Just observe how were we converting octal to decimal. See, what were we doing? Non-decimal part, we were raising to the power 0, 1, 2 as we were doing for my normal numbers. Then we were multiplying the base. And here we were taking 8 as we are talking about octal. But here we need to, what we need to do? We need to multiply 16. So let me take, suppose, 1, 2, FA. This is my answer. As I am every time saying, convert this first. So F is given. F means what? F is nothing but 15. But before that, let me solve this in a proper manner. This is non-decimal part. At first, non-decimal part. Non-decimal part is 2f. So this f is nothing but 15. And I will be raising to the power 0 and 1 as usual. And then I will be giving 16 to the power 0 into the number. F is nothing but 15. Then again 16 to the power 1 into the given number. Okay. So here I have got anything to the power 0, 1. So here 15 and this 16 into 2, that is 32. So here we have got 47, and my non-decimal part is solved. Now let me think about the decimal part. So decimal part I am having a is nothing but 10. In my non-decimal part I will be raising it to the my number that need to be raised, that will be -1. So here it will be 16 to the power -1 into the number. So it will be 1 by 16 into 10. If I will be solving this, 2 8 ja, 2 5 ja. Again let me multiply 125. Then it will be resulting in 1000. Here it will be 5 by 25. 5 by 25. 5 to the 10, then 12, then this is 6. So it will be resulting in 2.625. Okay, so whatever result we have got from the non-decimal part, I will be adding it with the decimal part. So if I will be suggesting, so here we have got 47. So 47 plus 0.625. That will give me 47.625. That's all. Now my hexadecimal is successfully converted to decimal. If you want to express, you can put parenthesis and then 10. Now we have already reached to the last question. I will be giving you a moment to think how you will be converting the decimal this. Okay, let me take, suppose this is a decimal it is given. Just think for a moment, students, how to convert this to hexadecimal. You can take the reference of this. How sir has converted my decimal to octal. Take the reference of this and try to solve this for a moment. Okay, let me solve. So now again, first the non-decimal part. Non-decimal part is 47. My decimal part is 0.625. Okay, now talking about 47. So as I was, when I was converting decimal to octal, I used to divide it with 8. So here I will be dividing it with 16. So 16 3 is 48. So it will be 16 2 ja 32. 5 and 1. So here it is 15. Again 16 0 the 0. This is 2. So here we have got 0 to 15. And 15 can be replaced with f. So 2f. Okay. This is how my non-decimal part is covered. Now thinking about my decimal part. What were we doing to our decimal part when we were converting decimal to octal? We used to multiply it with 8. So here, as I'm talking about hexadecimal, I will be multiplying it with 16. Which you need to think of. Approximately will be coming 0. 8, 10, 10. And I can replace 10. Directly we cannot write 10. I will be writing 8. See, here also I have considered my non-decimal part. Every time, whenever I will be multiplying, you need to talk about this itself. See, everywhere. So here also I have taken 10. You cannot directly take the 10. That's why I have taken 8. And I will be putting aside of this. Okay. So, can you see? I have written over here. And can you see? I have taken the result of my previous question to solve this. Okay. After taking the result of my previous question, here when I have tried to solve this, then this is what I have got. Understood? So we have, with this we have completed all the conversions in our number system. If you have learned something valuable from this particular video, Make sure to like to this particular video, subscribe to this particular channel, and press the bell icon for getting updates. Thank you so much, and bye bye.